So the first problem I'm looking at that seemed to be a problem was the absolute value of 3x minus 11 is greater than 10. Well, when you have absolute value is greater than, you're always going to get two tails of the number line or no solution or all real numbers. But you will never get a piece of the number line. That only happens when you have the absolute value that's smaller than some number. So that's an important concept. So when you have 3x minus 11 is greater than 10, it either means that 3x minus 11 is greater than 10, or 3x minus 11 is smaller than negative 10. Those are the two inequalities that are the same thing as the absolute value inequality. So then you add 11 to both sides and get 3x is bigger than 21. Divide both sides by 3 and you get x is bigger than 7. Add 11 to both sides here and you get 3x is smaller than 1. Divide by 3 and you get x is smaller than 1/3. Because it's the or, it's two pieces of the number line. So x is bigger than 7 or x is smaller than 1/3. So this is negative infinity to 1/3 union 7 to infinity. So that's the correct answer to the first one that you got incorrect. So the next one I'm looking at is your number 7. And you have the absolute value of x minus 5 equals the absolute value of 3 minus x. Well, there's two possibilities. Either x minus 5 equals 3 minus x, or x minus 5 equals the opposite of 3 minus x. That's the meaning of absolute value. Absolute value says the quantity inside is either positive or negative. The absolute value forces it to be positive. But if I want to find all the values of x that work, I have to look at both possibilities. So I'm going to add x to both sides here and get 2x minus 5 equals 3. Add 5, and get 2x equals 8. Divide both sides by 2 and get x equals 4. So you can check your answer here and say, does 4 minus 5 in absolute value equal 3 minus 4 in absolute value? Well, here I get 4 minus 5 is negative 1, so the absolute value is 1. 3 minus 4 is negative 1, so the absolute value is 1. So x equals 4 works. So now let's solve this other equality. Negative 3 plus x. Well, now we see that if I subtract x from both sides, I get 5 equals negative 3, which isn't true. So this part doesn't contribute anything to the solution, but you had to check it to make sure. So x equals 4 is the only answer. And it looks like your answer is 1, 8, and I'm not sure how you got that. So maybe if you could explain to me, I could be more helpful. And then let's look at the next one is number 9. And we have negative 5 times the absolute value of 3 minus x is less than negative 30. So I gave you a problem a lot like this on the ones I had you do to turn into Canvas so I could have a chance to make sure you knew how to do it correctly. If you divide both sides of an inequality by a negative number, remember that the inequality reverses its direction. That's what happens when you multiply or divide by a negative number. The two sides switch which side is bigger. So you have to make sure that the symbol is correct. So now I have a greater than in absolute value, so I know I'm going to have the two tails sort of a solution. So I either have 3 minus x is bigger than 6, or 3 minus x is less than negative 6. So I'm going to subtract 3 from both sides and get that negative x is bigger than 3. Divide both sides by negative 1, which reverses the inequality, and I get that x is less than negative 3. Subtract 3 from both sides, get negative x is less than negative 9, but when I divide both sides by negative 1, I reverse the inequality, and there's an or in between. So x is less than -3, or x is bigger than 9. And then my interval notation flows right out of my number line solution. So that's number 9. Number 10, it looks like you weren't sure about the degree of a polynomial. So you got most of the credit, but the degree of a polynomial is the biggest exponent you see on an x. So that would be if it only had x's. Because it has x's and y's, in the term 9x squared y to the 4th, you add those exponents together and you get 6. So it's the biggest number you find for an exponent, not the sum of the exponents. So hopefully that's clearer to you after reviewing. And then number 13, looks like you got close, but you combined two things that were not like terms. So you can only combine things if they have exactly the same variables with exactly the same powers. Otherwise, they don't add together. Okay, so let's look at number 15. And I have the absolute value of x plus 4 is less than or equal to 6. So this is one where you are going to have a piece of the number line because it's less than. So this is the type where you can write the compound inequality, which is equivalent of and. So you can do it as two separate problems. -6 is less than or equal to x plus 4, and x plus 4 is less than or equal to 6. But because those can be combined into a single compound inequality, that's usually how we work with it because it's easier. So you subtract 4 from each of the three parts and get -10 is less than or equal to x, which is less than or equal to 2. So I want all the numbers between -10 and 2 on the number line, which gives me interval notation of -10 to 2. And it looks like this one, it was mostly just your notation that you need square brackets when it's an or equals to, square brackets, so that it means the end points are included. This notation is used for set of. So we only use that if we're talking about a set of solution. So number 16. Looks like one of your lines isn't graphed correctly, so I'll let you double check that. I'll go through how you can graph these lines using intercept method. So you have 3x minus 4y is less than or equal to 12. So you first graph 3x minus 4y equals 12, which we were doing in the last chapter over and over and over, right? So you let x equal 0. So you have -4y equals 12. Divide both sides by -4 and get y equals -3. So when x is 0, y is -3. So this is one of your intercepts. Then you let y equal 0. So now I have 3x minus 4 times 0 equals 12. So 3x equals 12. Divide both sides by 3 and x equals 4. So you have 4, 0 is the other intercept. So it looks like you have 0, -3, but I don't see that you have 4, 0. So that looks like where the error is. So you might practice that a little more. And then let's look at number 18. And you have the absolute value of 3x minus 9 is less than -8. Absolute value is always greater than or equal to 0. It's either positive, greater than 0, or equal to 0, never negative. So there's no possible way you can get the absolute value smaller than a negative number. So that's why the correct answer is the empty set. Okay, and then number 20, I'm going to suggest that you look at the movie I made about f of a plus h that's in my math lab under movies made by Professor Hill, and let me know if that's not clear to you. And then number 24, Again, this was really similar to the one that I had you do in Canvas so that I could have a chance to correct your work and make sure you were doing it correctly. So you have to isolate the absolute value to begin. So subtract 10 from both sides. 2 times the absolute value of 2x minus 9 is greater than 6. Then you divide both sides by 2, and you get 2x minus 9 in absolute value is greater than 3. So it's greater than, so I know I'm going to have the two tails, kind of a solution. So I have 2x minus 9 is greater than 3, or 2x minus 9 is less than negative 3. So add 9 to both sides. 2x is bigger than 12. X is bigger than 6. Add 9 to both sides here. 2x is less than 6. X is less than 3. So I have x is less than 3, or x is bigger than 6. So I have negative infinity to 3, union 6 to infinity. That's the interval notation that matches up to my number line. And I'm not sure why you thought the solution set was the empty set, so maybe we could talk more about that. So hopefully that's helpful. Let me know if I can answer any more questions for you.